Alright, so in this problem, let's use a calorimeter to find the mass of something. It'll be crazy, like some kind of scale. So we're gonna have a vat of water, a calorimeter full of water, say at 20 degrees room temperature here, 20 degrees Celsius water, and we're gonna drop in some hunk of metal, say steel. So there's my steel, and the steel will be at like 100 degrees Celsius. It's hot, something hot, and we're going to drop it in there, so we can look up the specific heat of water and the specific heat of steel, right, if we need to. So we're going to go ahead and drop this in there, and eventually they'll come to agreement on the temperature, right? We'll have just after waiting long enough, the steel should be the same temperature of the water, and so we measure that final temperature, and we'll say that it is what 30 degrees Celsius in the end for the water and the steel. And we'll say that I had a mass of, just for simplicity's sake, 1 kilogram of water when we started this. So we're dropping in a piece of steel. We know the temperature, we know how much water we have, and we know the temperature of the water. We also know the final temperature of the system. We should be able to figure out the mass of the steel from this. Alright, so like most of these calorimetry problems, we start with the fact that the water, the energy that goes into the water comes out of the steel, right? And in this problem, there are no phase changes, right? None of the water is going to boil. Now I can say that for sure, pretty much for certain, because I've got 100 degrees of, oh well, actually no, I know it because, right, I know the final temperature is 30 degrees, so it's not going to come to a boil, and it's not going to freeze, and the steel certainly isn't going to melt or evaporate at those temperatures. So the only heats involved are these. So let's see, we know the mass of the water, we know that we can look up the heat capacity of water, we know the change in temperature of water, we know the change in temperature of steel, and we can look up the heat capacity of steel. So we can just solve this for the mass of the steel. Dividing the rest over, we're going to get that the mass of the steel is equal to negative mass of the water times C of the water, delta T of the water, over C of the steel, delta T of the steel. So there's another weird way that we can weigh something using a calorimeter, or take its mass rather, not weigh it. So just a good example of using this equation here. Oh, I'm not sure if it has a name, but basically the energy from one goes into the other if it's a perfect calorimeter. That's it.